Welcome to The Explainer. Today, we're going to pull back the curtain on a super simple but really powerful concept that basically keeps our digital world from turning into total chaos. It's called a queue, and it's pretty much just the idea of standing in line, but for technology. Have you ever wondered what happens when you and like 3 other people all hit print at the exact same time? How does the printer know whose document to print first so they don't all just get jumbled together? What's the invisible traffic cop directing all this?
Well, the answer is this really elegant idea that programmers use all the time. Seriously, it's one of the most fundamental building blocks in pretty much all of the software you use every single day.
And that idea is called a queue. Honestly, the best way to get it is to just forget about computers for a second and picture people lining up for movie tickets. You get in at the back of the line, right? And the person at the very front is the next one to get served. Super simple.
That really simple rule has a name: first in, first out, or as you'll often see it, FIFO. This is the absolute heart of the matter. The first thing that gets into the line is the first thing that gets to leave. That's it. That's the golden rule of the queue.
Okay, so to manage this digital line, we need a few basic commands. Let's take a look at the specific operations that actually make a queue, work.
It really boils down to 2 main actions. When a new item shows up, we enqueue it. That's just a fancy programmer word for adding it to the back of the line. And when we're ready to process the item at the front, we dequeue it, which just means we remove it so the next in line can move on up.
So here's the complete toolkit for managing a queue. Besides adding with enqueue and removing with dequeue, we can also just peek at the front element without actually removing it. And we can check if the queue is empty, to see if there's anyone in line at all. With just these 4 operations, you can control any queue.
Okay, so we know the rules, but how does a programmer actually build one of these things? Well, it's actually a neat little story about finding a problem and then coming up with a really clever solution.
So the most straightforward way to build a queue in code is with something called an array. You can just think of it as a row of a fixed number of parking spots. We use 2 little markers, or pointers, to keep track of the front and the rear of our line. Seems easy enough, right?
But let's think about this for a second. We add a few items, no problem. Then we serve a few items from the front. Our little front marker moves forward. So, what's the catch?
And here it is. This is the problem. See all those empty slots at the beginning of the array where items used to be? They're now just wasted space. We can't use them again, and that is super inefficient. So programmers came up with this brilliant fix. Instead of a straight line that just ends, what if the end of the line could loop back around to the beginning? This is the circular queue. The big idea here is that when the rear pointer hits the very last slot, it just wraps around to the start of the array to fill any of those empty spots we had before. It's done with a clever little math trick using something called the modulo operator. The bottom line is, no space is ever wasted. It's a fantastic, elegant solution.
Now, a circular array is awesome, but it does have one limitation. You have to decide its size ahead of time. So what if you have no idea if you're going to get 10 requests or 10 million? For that, programmers have another tool called a linked list. As you can see, a linked list isn't a fixed block. It's a dynamic chain that can grow and shrink as needed. So there's a trade-off. An array is super efficient if you know the size, but a linked list gives you flexibility when you don't.
Okay, let's pause right here, because this idea is what makes queues so incredible from a performance standpoint. Both adding and removing an item are what we call an O of 1 or constant time operation. In plain English, this is huge. It means that serving the next person in line takes the exact same super tiny amount of time whether there are 10 people waiting or 10 million. The length of the line makes 0 difference to the speed, and that's what makes queues so amazingly efficient.
Now, for the really fun part. We've gone through the theory, but where is this stuff actually working behind the scenes in your life? You might be surprised.
Literally every time you click your mouse or type on your keyboard, your computer's main processor, its brain, is using a queue to figure out what to do next. We already talked about print jobs, and that little buffering circle you see on a streaming video, yep, that's a queue filling up with video data ahead of time so your movie plays nice and smooth. They are the invisible, orderly heroes of our digital world.
So, after all that, what's the one single thing you should walk away with? How do you really lock this concept into your brain for good?
It all comes down to this. A queue is all about orderly processing. First come, first served. Anytime you have a situation where you need to handle things in the exact order that they arrived, a queue is almost always the right answer.
All right, let's do a quick little challenge to see if you've got it. Imagine we start with an empty queue. We NQ the number 10. Then we NQ 20. After that, we DQ whatever is at the front, and finally, we NQ 30. So, what number is at the front of the line now? Take a second.
Did you get it? The answer is 20. We put in 10, then 20. When we DQ'd, the 10 got removed because it was first. That left 20 at the front. Adding 30 to the back doesn't change who's at the front of the line. If you followed that logic, you have absolutely nailed the core concept of how queues work. Fantastic job!